Hello everyone, my name is Richard Zhang, and I'm a technical marketing engineer here at Cisco's Wireless Enterprise Networking Business Unit. I'd like to welcome you to episode 1 of a two-part series where I'll be going over a rapidly growing technological phenomenon, and that is the Internet of Things and how Cisco is spearheading this technology's popularity with their state-of-the-art application hosting solution embedded directly on their Catalyst series Wi-Fi 6 access points. In today's episode, I'll be starting off by deep diving into the technical aspects of this feature, which includes an overview of the deployment topology and network architecture. Then, I'll follow it up with a deployment workflow where I'll show you how you can go from developing the application to deploying it to your wireless infrastructure. Lastly, I'll finish this off with a demo on Cisco DNA Center regarding exactly how we can execute the deployment workflow. To get started, let's jump directly into the typical topology of an application hosting deployment. As a quick recap, this state-of-the-art application hosting platform is built directly into the Catalyst access point code itself. Other than the additional step of inserting an IoT USB connector into the access point's USB module, no additional physical change to the standard Cisco DNA Center, wireless controller, and access point deployment is required. As for the third-party Dockerized fog-enabled IOX application, what happens is that Cisco DNA Center acts as the fog director that deploys it to all targeted access points, and all these access points then take on the role of an IoT gateway that enables a third-party application server to communicate with IoT devices surrounding the access point's physical location. This is the topology of a general application hosting deployment, but let's dive deeper to understand the network architecture level of the deployment. The network architecture of application hosting starts off with fundamental connections staple to every wireless Cisco deployment. On the left, we have Cisco DNA Center, which is connected to the Catalyst 9800 WLC through a TLS native tunnel. The Catalyst 9800 WLC is then connected to a Catalyst 9100 series access point through a CAPWAP tunnel, standard to all wireless deployments. As for the IoT USB module on the access point, it operates with a USB serial protocol at a baud rate of 115200, allowing support for majority of available IoT USB connectors. This is the basic hardware topology that supports application hosting, and although it looks simple, the application hosting platform on the Catalyst access point itself has actually been well thought out and designed in a way to allow developers to focus on creating incredible IoT applications by providing a quick turnaround time. One example is that Cisco DNA Center and the Catalyst access points actually have a direct HTTPS communication with each other. This connection is how Cisco DNA Center will send the access point the application to download, and the access point will be able to use this channel to reply with an acknowledge and other metadata relevant for application lifecycle management. The advantage of this direct connection is that it greatly speeds up an application's deployment time, allowing a developer to deploy their developed application throughout their entire network for validation quickly and with very little downtime. Another example is that when an application is deployed onto an access point from Cisco DNA Center, it'll automatically receive an IP address in the range of 192.168.11.x with a subnet of 27 from the DHCP server built into the access point's control plane. Although this subnet is probably different from the VLAN of the rest of the devices in your wireless deployment, with this local IP address, the application can still easily communicate externally through NATing the access point's management IP. This design allows all deployed applications to both effortlessly and securely communicate with anything it needs to in the network. With that being said, this is the network architecture of application hosting. Now that you have a general idea of how data communication works within the application hosting topology, let's talk about how you can get started with planning and developing your first IOX application. Cisco's definitive goal for application hosting is to enable anyone with a desire to innovate in the field of IoT to have the ability to leverage Cisco Catalyst access points as a platform to propagate the creative spirit through software development. Cisco's engineering team's software development workflow for application hosting has been groomed meticulously into an incredibly straightforward and systematic process. Cisco's DevNet page, which I've linked within the description below, encapsulates this entire process into an intrinsic step-by-step walkthrough, allowing any developer to go from software planning to developing in a matter of minutes. Once we enter our DevNet page, it'll start off by providing you with an overview on application hosting on the Catalyst access points feature. the architecture, and use cases, which is similar to what we've gone over in this series. By clicking on Getting Started, you'll be met with a list of device prerequisites necessary for building your first application. Then, by clicking on Create Your First iOS Application, you can walk through each page starting from requirements down to verify on Catalyst Controller, and it'll walk you step by step through how you can create your first application. At any point, if you run into any questions or issues, simply refer to the Frequently Asked Questions section, or reach out to your Cisco support point of contact. With that being said, I'll leave you to read our DevNet page in detail, and this concludes the planning and development part of the application hosting process. With our application now developed, we can move on to the next part of the process, which is the application deployment workflow. To allow the application deployment process to your access points to be incredibly smooth, the team has created an intuitive 4-step process that enables users to go from setting up Cisco DNA Center to reaping the IoT benefits with minimal effort. Cisco's intent-based networking platform, Cisco DNA Center, enables such a quick and easy workflow by providing users with an aesthetic user interface to deploy and manage the application's lifecycle. Starting off with day 0, we have Cisco DNA Center configurations, in which we'll set up basic configurations such as creating a network hierarchy site, discovering wireless devices, and assigning devices to the network hierarchy site. Next, we have day 1, where we have upload and deploy iOS application, in which we'll upload the application we've just developed prior to Cisco DNA Center, then deploy it to each of our desired access points. Upon completing this step, we have day 2, where we have manage and monitor application, in which now that we've successfully deployed our application to our access points, we can now establish a channel of communication between the application and its third-party application server. As an FYI, the details of this step completely vary from application to application because the steps to establishing this communication entirely depends on how the software was designed. Once this is completed, the deployment workflow is pretty much finished and you can begin enjoying the benefits from your IoT deployment. However, as with all software, from time to time you'll observe areas in which you would like to improve on, and this takes us to day N, where we have management optimization. The purpose of this section is to validate how your application is performing in the field, find user pain points, develop enhancements, and upgrade the application through Cisco DNA Center. This step is called day N because application improvement can continue infinitely into the future as long as the application is in use. To summarize this discussion, these 4 steps make up the entirety of the application hosting deployment process. Now that you have a solid understanding of the general topology, network architecture, as well as deployment workflow, let's jump into a demo where I'll show you exactly how we can deploy an application to the access points. When you log into Cisco DNA Center, you'll end up at this homepage. In order to get started with the application deployment process, we'll need to first set up day 0 configurations as discussed earlier in this video. If you're familiar with this day 0 configuration process, you can go ahead and click on the time marker next to day 1 configurations in the description below, and this will skip you ahead to where we'll be uploading and deploying our application to our access points. With that being said, let's get started with our day 0 configurations. The first thing we need to do is create a network hierarchy site that depicts the exact location of where your wireless infrastructure is located. To do so, we need to navigate to the network hierarchy page, and we can do so by opening the menu, clicking on Design, then Network Hierarchy. As you can see here, I already have a number of sites created, but let's go through the site creation process step by step. This network hierarchy page's design works in a way where at the top of the hierarchy, we have a parent site named Global, which is a parent to all your network sites. One level below Global, we have areas, which typically represents a city, such as Los Angeles, Palo Alto, Pleasanton, and so on. If we click on this caret to the left, we can expand one of the areas, and you'll see that within areas, we have buildings, which typically represents an office. When we expand the building, we now enter the most granular part of the network hierarchy page, which is the floor. In order to create any of these sites, our first option is to click on the Add Site button at the top, which will allow you to create an area or building within Global, a building within an area, or a floor within a building. Similarly, we can also click on any of these gear icons next to Global, the areas, or the buildings to create a child site within that site. When creating a building, it'll prompt you to enter either your building's physical address or latitude-longitude coordinates. The reason we need this information is because the purpose of Cisco DNA Center is to allow you to track your exact network deployment location for management purposes. When creating a floor within a building, it'll allow you to upload a picture of your floor map, which will allow you to deploy your APs onto the floor for an RF view. For the purpose of this demo, let's go ahead and just continue using the network hierarchy sites I've already created. Now that we have an understanding of how our network hierarchy page works, let's go ahead and discover our wireless LAN controller and access points onto Cisco DNA Center. To do so, we need to navigate to the Discovery page, and can do so by clicking on the Cisco DNA Center logo at the top of the page to return to the home page. Then, we can scroll down to the bottom of the page, click on the Discovery grid, then add Discovery. Here, we've entered the Discovery page, where we can enter in a discovery name, which is just a label to help you identify the device or devices you're trying to discover onto Cisco DNA Center. Let me go ahead and enter in IoT_WLC. Next, we can enter in a single IP address or range along with the corresponding subnet of the device or devices we're trying to discover. Let me go ahead and enter in 10.10.107.19, and under subnet 255.255.255.0, which points to my 9800 Catalyst wireless controller. Then, scrolling down below, if it's not already added, you can click on Add Credentials to include mandatory information for discovering your WLC. This includes the SSH credentials, SNMP read and write credentials, and netconf port, which is by default 830. I've already added this information prior and have saved it onto this Cisco DNA Center, so I can go ahead and just click on Discover. After a short period of time, at the top right-hand corner of the page, if your WLC is reachable to Cisco DNA Center, you'll be able to see a green check appear under Status, ICMP, SNMP, CLI, and netconf, meaning the device discovery was successful. At this point, we've completed device discovery, and we can proceed on to the next step, which is assign our controller and joined APs to the network hierarchy sites we've discussed earlier. To do so, we need to navigate to the inventory page, and we can do so by opening the menu, clicking on Provision, and then Inventory. Here in the inventory page, we can click on Unassigned Devices, and you'll be able to see the WLC we've just discovered along with its joint APs. Let's start off by assigning my WLC to a building. To do so, I can click on the checkbox next to the device, hover my cursor over Action, Provision, then Assign Device to Site. Here, I can go ahead and click on Choose a Site, then navigate to a specific building I would like to deploy my controller to. My controller is located within SJ04 within the San Jose area, so I'm going to select that and hit Save. Then Next. Then, I can go ahead and click Assign, and my WLC is now successfully assigned to that site. Next, I can assign my access points to a floor within that building. Again, I can select the checkboxes next to those access points, hover my cursor over Actions, Provision, then Assign Device to Site. Here, I'm going to choose Floor 1 within my SJ04 building, where my access points are deployed. Click Save, then Next. Then, I can go ahead and click Assign, and my access points are now successfully assigned to that site. To confirm all my devices are indeed there, I can expand San Jose on the left and click on SJ04, and sure enough, my wireless controller and access points are there. At this point, we have one last step in completing the Day 0 configurations, and that is to assign our access points to a location within the floor map. To do so, we need to navigate back to the network hierarchy page, and we can do so by opening the menu, clicking on Design, then Network Hierarchy. Here on the network hierarchy page, let's go ahead and navigate to the floor where we've assigned our access points to earlier. On the top right hand side of the screen, you'll notice an alert with the number 2 and a flag symbol next to it, and this means that there are 2 devices ready for placement on the floor map. This is of course referring to the 2 access points that we've just assigned to this floor. To place those access points onto the floor map, we can go ahead and click on Edit at the top, then click on Position next to access points. Then, you'll notice 2 access point icons representing the 2 access points we've just assigned to this floor has appeared. Go ahead and drag these two icons to a place on the floor map that best represents where the access points are physically located. And then click Save. At this point, our Day 0 Cisco DNA Center configurations are officially completed, and we can move on to Day 1 with uploading and deploying our IOX application. Before jumping in, I wanted to bring up that we have two prerequisites for this section. The first prerequisite is that you must have the fully developed IOX application that you would like to deploy stored on your local computer. The second prerequisite is that we need to ensure that our Cisco DNA Center is on a version of 2.1 or above with the application hosting package installed on it. To check on my Cisco DNA Center's version, I can simply click on the question mark at the top right-hand corner of the screen, then click on About, and you'll notice that my cluster does indeed have a satisfactory version of 2.1. To check if we have the application hosting package installed, we can click on Packages right below, and you'll notice that we do have the application hosting package listed right there, meaning that it has been properly installed. If this package is not listed here, make sure to download and install it by following the steps on our deployment guide. Or, if you're having issues locating this package, go ahead and reach out to your Cisco point of contact and they would be happy to assist you. With that being said, let's go ahead and proceed with our Day 1 configuration, starting with uploading our IOX application. To upload our application, we need to enter our IoT services page, and to do so, we can open the menu, click on Provision, then IoT Services. Here on the right of the page, we can click on New Application to start this uploading process. Then, we can select our package type, where we have the option to choose either Docker or Cisco package. The application I'll be uploading today is an SES Imago Tag package, which is a Cisco package, so I'll go ahead and select that. Below that, we can select our package category, in which we have monitoring, security, IoT, and others. My application is a monitoring application, so I'll select that option. As an FYI, both these options vary based on how the application was created during the time of development, so the options selected will vary from application to application. Now that we've configured our package type and category, we can go ahead and click on Select, browse our local computer to the location of the file, and select it. Then, upload the file by clicking on the Upload button. At this point, our application should have appeared on the left-hand side of the screen, meaning that it's been successfully uploaded to Cisco DNA Center. If we wanted to manage the application we've just uploaded, we can click directly on the application itself, and it'll take us to an applications management page. Here on this page, we can click on Edit at the top to change the icon of the application. Click Edit on the right to edit the application description and Docker runtime option, which for example, can be used by administrators to enable a debug mode on the application for troubleshooting. We can also click on Update Application at the bottom to upload a new version of this application, or Delete Application to remove the application from Cisco DNA Center. Let's go ahead and just leave everything as default, and now we can consider the upload portion of Day 1 configuration to be completed. Next, let's go ahead and deploy our application to our access point we've discovered earlier. To do so, we need to navigate to the IoT Services page, and can do so by opening the menu, clicking on Workflows, then clicking on Enable IoT Services. Upon clicking on it, a modal box will appear with a high-level walkthrough explaining the workflow we're about to go through when deploying the application. Let's go ahead and click on the Let's Do It button to get started. On the first page of the application deployment workflow, we'll start off at the Select Site page. What we need to do is select the floor that we want to deploy our application to. So let's go ahead and select the floor that we've assigned our APs to earlier. Then hit Next. On the next page, we can select the application we would like to deploy. Then hit Next. On the following page, we'll now be met with the table of access points assigned to the floor we've selected. To choose which access points we want to deploy our application to, we can go ahead and click on the checkbox next to the desired access point. Similarly, if I click on the Map button at the top, we'll have the option to see a map view of the access points currently deployed on this floor, and to select them, we can click directly on the access point icons. Then, we can click on Next, and we'll arrive at the summary page, where we can review the details to ensure that we've selected the correct application to deploy to the correct access points, and then hit Next. Lastly, we'll arrive at the provisioning task page where we can note down the task name for future reference, then hit provision. Once you hit provision, Cisco DNA Center will begin attempting to deploy the application to the selected access points. If the application deployment is successful, we'll see a green provision status appear. In the case that the application fails to deploy, we'll see a red failed status appear. Then, by clicking on View Details and by hovering over the status, you'll get a failure reason. As you can see here, one of my applications succeeded during provisioning while the other had failed. There could be many reasons for failure, such as the connection between the access point and Cisco DNA Center breaking during image deployment, or perhaps a corrupted application file. But in this case, it's because this application I'm attempting to deploy has a dependency on an IoT USB connector which I had not inserted into the access point. You'll notice this error message says exactly this when it reads, USB device not found. This is a great segue for me to remind you to insert any dependent USB connector into the access points prior to image deployment, as it is a prerequisite. With that being said, this was an intentional failure, and since our application has been successfully deployed onto one of our access points, let's go ahead and click on Next to enter into the task completion page. At this point, we can begin monitoring the deployment of our application. To do so, we can go ahead and click on the Manage IoT Applications button to enter the Applications Management page. On this page, you'll be able to monitor the status of your deployed applications as shown in the App Status column. To perform an action on an application deployed on your access point, you can select an access point through the checkbox on the left and then hover your cursor over Actions. Here, you'll have 5 options. Start App, which is to start a stopped app. Stop App, which is to stop the runtime of the deployed application. Edit App Config, which will allow you to add additional configurations to your application. Upgrade App, which will upgrade the application if you've uploaded a new version in the Enable IoT page where we initially uploaded our application. And Uninstall App, which will entirely remove the application from our access point. For the purpose of this demo, let's go ahead and leave all these configurations as default. And at this point, we've officially completed the day 1 deployment of uploading and deploying our iOS application. We now have our next step of deployment, which is day 2, where our application is ready for communication with our third-party application server. However, this part of the process entirely varies between each application, as it completely depends on how each application and server is designed. One example I can provide is for the case of SES Imago Tag. The SES Imago Tag application server is called Fusion Cloud, and as the name has it, resides in the cloud. After the application is deployed onto the access point, it'll automatically know which host to reach out to. Through the network's DNS server, the application will be able to resolve the Fusion Cloud hostname into an IP address and discover the application server like that. After the application discovers Fusion Cloud, it'll automatically show up on the server's UI, where further communication can be managed and monitored. With that being said, this concludes episode 2 and the last episode of the Internet of Things powered by Cisco's application hosting on the Catalyst Access Point series. If you would like to learn more about application hosting, I've provided a link within the description to the Features Official Deployment Guide. I hope you found learning about Cisco's state-of-the-art Internet of Things solution not only to be educational, but also exciting. If you've enjoyed this series, please give this video a thumbs up and subscribe to our YouTube channel, and as always, thank you for watching.